Gadi Institute of Engineering and Technology, NH16 Anakapalli, Visakhapatnam.
Hi students, in this video lecture I am going to explain EM wave polarization concepts. So the types of polarization and proofs. Polarization means the physical orientation of electric field in a free space is called polarization. So basically polarizations are three types: linear polarization and circular polarization and elliptical polarization. So here electric field of electromagnetic wave, for example in x direction, Ex is equal to A into cos omega t minus beta z. This is the electromagnetic wave equation, very popular equation. Okay. So Ey is equal to B into B, nothing but magnitude here, small b into cos omega t minus beta z plus alpha. Here alpha is the phase difference between x component and y component. Okay, so this is z axis, wave is propagated in z direction along the z axis. Okay, so from this equation, Ex is equal to A cos omega t minus beta z. From this equation, Ex by A is equal to cos omega t, cos omega t. So here assume z is equal to 0. At z is equal to 0, Ex by A is equal to cos omega t. Put z is equal to 0, so beta into z, obviously 0, so cos omega t, A cos omega t. So Ex by A is equal to cos omega t. So based on this equation, sin omega t, sin omega t is equal to sin theta is equal to square root of 1 minus cos square theta. So by using that formula, simply you can say sin omega t is equal to 1 minus Ex by A whole square, otherwise Ex square by A square. So this is sin omega t. Now coming to this equation Ey. So from this equation, so at z is equal to 0, what happened? Ey by b is equal to cos omega t plus alpha, Okay, right? Here alpha is the phase difference between x component and y component. So this is in the form of cos A plus B. So cos A plus B. So we know that cos A plus B is equal to cos A cos B minus sin A minus sine A into sine B. This is equal to cos A plus B formula. Okay, cos A plus B. Now, based on this formula, cos omega t plus alpha. Here, cos omega t plus alpha is there. So, cos omega t plus alpha is equal to cos omega t into cos alpha minus sine omega t sine alpha. So this alpha is nothing but the phase difference between x component and y component. So from this equation, cos omega t is equal to Ex by A. Cos omega t is equal to Ex by A. So, and sin omega t is equal to 1 square root of 1 minus Ex by A whole square. So, substitute these values in this equation. So, here cos omega t is equal to Ex by A into here cos alpha. Sin omega t is equal to square root of 1 minus Ex square by A square into sine alpha. So here simply cos A plus B is equal to cos A cos B minus sin A sin B. So cos omega t plus alpha is equal to cos omega t cos alpha minus sin omega t sin alpha. So based on the equations, cos omega t is equal to Ex by A cos alpha as it is written minus sin omega t is equal to 1 minus cos square omega t. So square root of 1 minus Ex square by A square into sin alpha. Okay. This is equal to cos omega t plus alpha. This is equal to cos omega t plus alpha. What is cos omega t plus alpha? Ey by b. So equating this equation to Ey by b. Equating this equation to Ey by b. Equating this equation to Ey by b. Now, by simplifying, Ex minus A cos alpha minus Ey by b is equal to square root of 1 minus Ex square by A square into sine alpha. Here Ex by A cos alpha, this plus becomes minus, so minus Ey by b is equal to this minus value becomes plus in LHS side. So obviously this is equal to square root of 1 minus Ex square by A square into sine alpha. Squaring on both sides. What happened? Squaring on both sides. So this is A minus B whole square. Ex by A cos alpha minus Ey by b whole square is in the form of A minus B whole square. So A square, that means Ex square by A square cos square alpha, this is equal to A square minus 2ab, 2 into Ex by A into Ey by B, Ey by B cos alpha plus B square. So Ey square by B square. So this RHS side equation becomes, here square and square root cancel, so 1 minus Ex square by A square into, this is sine square alpha, sine square alpha, sine square alpha, sine square alpha. So this RHS side equation becomes sine square alpha minus Ex square by A square into sine square alpha, right? So instead of this one, simply substituting this value. Here only multiplication, sine square alpha into 1 is equal to sine square alpha minus Ex square by A square into sine square alpha. This minus Ex square by A square sin alpha becomes plus Ex square by A square sin alpha at LHS side. To bring this minus Ex square by A square sin square alpha in left hand side, it will become the plus Ex square by A square sin square alpha. So here Ex square by A square is taking common. Sin square alpha and cos square alpha. Sin square alpha plus cos square alpha is equal to 1. So that term becomes simply 1. So Ex square by A square into 1 is equal to Ex square by A square minus 2 into Ex into Ey by AB into cos alpha plus Ey square by B square is equal to sine square alpha. This is our final equation. So here alpha is the phase difference. That means the phase difference between these two, this Ey and Ex is equal to 0. What happened? For example, alpha is equal to 0. Phase difference between X component and Y component. What happened? Cos alpha, that means cos 0. Cos alpha is equal to cos 0. So cos 0 is equal to 1. So that means this term becomes 2 into Ex Ey by AB. This term. Alpha is equal to 0. Sin alpha is equal to, that means sin 0. Sin 0 is equal to 0. Simple. So entire this RHS term automatically 0 becomes 0. Sin square alpha, 0 square is equal to 0. So finally, here what happened? The remaining equation seems to be like that. Ex square by A square minus 2 into Ex Ey by AB. Cos alpha is equal to 1. That's why here no need to write cos alpha plus Ey square by B square is equal to 0. Why? Because the phase difference, assume the phase difference between Ex component and Ey component alpha is equal to 0, then sin alpha becomes sin 0, that is equal to 0. 0 square is equal to 0. So this entire equation seems to be like that. x my a minus ey by b whole square. That is equal to 0. That is equal to 0. Just this equation is looks like a minus b whole square form. So it becomes ex by a minus ey by b whole square. So squaring on both sides, we will get ey by b is equal to ex by a. Okay, simply, here square root is applied simply. What happened? Both LHS and RHS. Then ex by a is equal to ey by b. So ey is equal to b by a into ex. So this is in the form of, it is similar to y is equal to mx form. Y is equal to mx form. Just imagine here x-axis ex is there, y-axis ey is there. So y is equal to mx form. So this is nothing but the linear polarization. Linear polarization. So for example, if B is equal to 0, that means magnitude of the electric field in y direction. What happened? B is equal to 0, Ey is equal to 0. Why? Because 0 by A is equal to 0, automatically Ey is equal to 0. So Ey is equal to 0 means there is no electric field component on y-axis, only x component is existed. So this is called horizontal polarization. This is called horizontal polarization. Horizontal polarization. This is called horizontal polarization. Horizontal polarization. Suppose if A is equal to 0, what happened? In this case, B by A is equal to infinite. A is equal to 0, B by A is equal to infinite. That means simply Ex is equal to Ey by infinite. So anything by infinite is equal to 0. So A is equal to 0, simply Ex is equal to 0. Just substitute the values in this equation. So B is equal to some magnitude, A is equal to 0. Anything by 0 is equal to infinite. So that Ey by infinite is equal to Ex. So obviously Ex is equal to 0. That means X component is it. There is no electric field in X component. Obviously it is called vertical polarization. Only Y component is existed. So vertical polarization is existed. Vertical polarization. So now coming to the other cases. What is the actual equation? Just observe it. Ex square by a square minus 2ex ey by ab cos alpha plus ey square by b square is equal to sin square alpha. Right? This is actual equation. I will write actual equation once again. So ex square by a square minus 2ex ey by ab cos alpha plus ey square by b square is equal to sin square alpha. Okay, if in case 2 alpha is equal to plus or minus pi by 2, here the phase difference between Ex component and Ey component is 90 degrees. Assume A is equal to B is equal to B. Okay. So what happens simply, if alpha is equal to 90 degrees, cos alpha, cos 90 is equal to 0. So entire this term is suppressed. This term is equal to 0. Cos 90 is equal to 0. Obviously 0 into anything is equal to 0. So in case 2, Ex square by A square, and one more condition, A is equal to B. So instead of A, simply here, instead of B, simply here, A is substituted. Why? Because A is equal to B. That is case 2. Sine square alpha. Alpha is equal to 90. So sine square 90, that is equal to 1. So by simplifying, this is equal to Ex square plus Ey square is equal to A square. This is the equation of circle. So this is called circular polarization. This is called circular polarization. Okay. So the equation seems to be like that, a circle equation. So it is nothing but a circular polarization. For example, here Ey is there and Ex is there. The difference between Ex and Ey is equal to 90 degrees plus pi by 2. Assume plus pi by 2. That means 90 degrees. Okay. Phase difference between Ex and Ey. So at z is equal to 0, at z is equal to 0, at z is equal to 0, Ey is equal to A cos omega t plus pi by 2. What is the actual equation of Ey? What is the actual equation of Ey? A b cos omega t minus beta z plus alpha. Here z is equal to 0. So obviously beta z is equal to 0. So cos omega t minus beta z. So here minus beta z is equal to 0 plus alpha. Alpha is equal to plus 90 degrees. So plus pi by 2. Instead of B, here A is substituted. Why? Because the condition A is equal to B. So instead of B, here A is substituted. So Ey is equal to A into cos 90 plus theta. Cos 90 plus theta is equal to minus sine theta. So this vector shifted at minus value. Here Ex is as it is, A cos omega t at z is equal to 0. So what about the resultant vector? The resultant vector, this is the resultant vector. So at z is equal to 0, Ey shifts towards negative. Okay. So here the wave is moved in clockwise direction. If alpha is equal to minus pi by 2 and z is equal to 0, Ey is equal to A cos omega t minus pi by 2. Then Ey is equal to plus A sin omega t. So this Ey is shifted positive towards positive value. So the resultant vector, here the resultant vector seems to be like that. This is the resultant vector. So the wave is moves in anti-clockwise direction. Anti-clockwise direction. Okay. So here circular polarizations are classified into two types. Left-handed circular polarization. These concepts are very important in GATE exam. And right-handed circular polarization. So here the phase difference between Ex component and Ey component is equal to pi by 2. Is equal to pi by 2. So wave moves in clockwise direction. Wave moves in clockwise direction. Just observe this diagram. Wave moves in clockwise direction. Phase difference is pi by 2. So Ey shifts negative. The resultant vector seems to be like that. Here resultant vector is wave moves in the clockwise direction. So wave moves in the clockwise direction. Assume wave travels inside the paper. Wave propagates inside the paper. For example, then this is nothing but right-handed circular polarization. Right-handed circular polarization. So here circle is seems to be like here circle is there. Okay. Wave is propagated in clockwise direction. Wave is moves in the clockwise direction. Wave is propagated inside the paper. Inside the paper. Okay. Phase difference is alpha. Alpha is equal to pi by 2 between x component and y component. This is nothing but right-handed circular polarization. Suppose the phase difference between Ex and Ey is minus pi by 2. So Ey value shift towards positive. Ey value shift towards positive. So the resultant, the wave moves in the anti-clockwise direction. Wave moves in the anti-clockwise direction. So here circle is there. Wave is moves in the anti-clockwise direction. Wave is moves in the anti-clockwise direction. This direction wave is moving. So assume the wave propagates inside the paper. Then it is called left-handed circular polarization. Left-handed circular polarization. For example, wave is propagated outside the paper. So this becomes right-hand circular polarization. This is very important concept. So suppose here the wave is propagated outside the paper. So this becomes left-handed circular polarization. Left-handed circular polarization. Okay. Now another case. If the phase difference between Ex component and Ey component is equal to 90 degrees, plus or minus 90 degrees, that means plus or minus pi by 2, and A is not equal to B. A is not equal to B. What is the actual equation? Ex, just I will show actual equation once again. Ex square by a square minus 2 into Ex Ey by ab cos alpha plus Ey square by b square is equal to sin square alpha. This is actual equation. Okay. So I will right? Actual equation here, ex square by a square minus 2 into ex ey by ab cos alpha plus ey by b square by b square is equal to sine square alpha. This is actual equation. So what is the condition? Alpha is equal to 90 degrees phase difference. A is not equal to B. So cos 90 is equal to, instead of alpha here 90 pi by 2 is substituted. Cos 90 is equal to 0. So 0 into anything is equal to 0. Obviously this value is equal to 0. So final equation is equal to ex square by a square plus ey square by b square. Sine square alpha, sine 90 is equal to 1. So 1 square is equal to 1. So ex square by a square plus ey square by b square is equal to 1. This equation is nothing but ellipse equation. This equation is nothing but ellipse equation. So here this is equal to ex and this is equal to ey. The elliptical polarization ellipsis seems to be like that. Okay, that means difference between ex component and ey component is 90 degrees. Magnitudes are different, then it is called elliptical polarization. Elliptical polarization. For example, if wave moves in this direction, okay, assume the wave propagates outside the paper, then it is called left elliptical polarization, left-handed elliptical polarization. Wave propagates outside the paper, opposite to me, so it direction is clockwise direction. So right hand side movement, but it is opposite to me. That means wave propagates outside the paper. So then it is called left elliptical polarization. Suppose here the wave propagates in anti-clockwise direction and wave moves in anti-clockwise direction and propagates outside the paper. Propagates along the z-axis outside the paper. So this is anti-clock. Originally it is left-handed circular polarization, but wave propagates outside the paper. So we have to take opposite direction. So this is called right-handed elliptical polarization. Right-handed elliptical polarization. Now another case. Suppose alpha phase difference between x component and y component is not equal to pi by 2 and not equal to 0, and a is not equal to b, then this is also called elliptical polarization. Here the ellipsis seems to be like that. This is this is x-axis, this is y-axis. Orientation of ellipsis seems to be like that. Orientation of ellipsis seems to be like that. So this is major axis A. This is minor axis. This is minor axis B. Minor axis B. So A by B is called axial ratio. Axial ratio. one of the important wave parameter. Especially it is very popular questions in competitive exams. If axial ratio is equal to infinite, axial ratio is range is between 1 to infinite. 1 to existed between 1 to infinite. Okay. If AR is equal to infinite, that means A by B is equal to infinite. A by B is equal to infinite. Okay. So A by infinity is equal to B. So that is equal to 0. So minor axis is equal to 0 means simply it is becomes a linear polarized wave. Linear polarized wave. If axial ratio is equal to 1, so A by B is equal to 1. That is so A is equal to B. So then this is called circular polarization. Phase difference 90 degrees. Phase difference is existed and A is equal to B. Then this is called circular polarization. Okay. So this is the polarization of electromagnetic waves. The final conclusion, there are three types of polarizations. One is linear polarization, and again linear polarizations are classified into two types: horizontal polarization and vertical polarization. Okay, condition here, phase difference between x component and y component is 0 degrees. Phase difference between x component and y component is 0 degrees. Next one is circular polarization. So in circular polarization, condition is alpha, phase difference between x component and y component is equal to 90 degrees plus or minus 90 degrees plus or minus 1 by pi by 2, and A is equal to B. A is equal to B. A and B are the magnitudes of electric field. Okay, in x component and y component respectively. Now coming to the elliptical polarization. Third one is elliptical polarization. Okay, the phase difference between Ex and Ey is plus or minus pi by 2, plus or minus pi by 2, and A is not equal to B. A is not equal to B. Then this is called elliptical polarization. X square by A square plus y square by B square is equal to 1. Similarly, Ex square by A square plus Ey square by B square is equal to 1. So, and another special case, alpha is not equal to 0, comma, alpha is not equal to pi by 2, not equal to pi by 2, A is not equal to B. A is not equal to B. Then that is also called elliptical polarization. That is also called elliptical polarization. That ellipsis seems to be like that. Okay. So based on the orientation of the wave, we will classify whether it is right circular or left circular, whether it is right elliptical or left elliptical. For example, wave is propagated inside the paper, and how wave travels clockwise or anti-clockwise decides the polarization, left-handed or right-handed polarization. Okay, right? Thank you, students.